parameter. This is the equation. R equal to A, the flow area, and then P is the weighted parameter. Okay. And then next parameter we have D, the hydraulic depth. Okay. So this one is the ratio between flow area and top width. Okay. So this is the equation, D equal to A over T. So the top width here is referred to the top width of the water surface, not the channel section. Okay. And then next we have Z, as you can see here. Okay. It is a side slope where Z is the horizontal distance. Okay. So for rectangular channel, the Z is 0 lah sebab dia tak ada sudut sending channel tu kan. So Z only applicable for trapezoidal and triangular channel. Okay. And then next we have W, small w here, for the side length of the channel slope. Okay. So W is located at from here to here. This one is W. This is the length of the side slope. Okay. And then you can refer this table, how to calculate the area, weighted parameter, top width, R, and also D. Depends on the channel shape. So we have rectangular, trapezoid, and circle. This one is the popular, or we call it the common shape for the open channel. Okay. So rectangular, trapezoidal, and also circle. Circle to represent culvert. Boleh ke? Ke laju sangat? Ke slow sangat? Boleh je. So basically in test and exam, so we don't provide the equation, so you need to memorize lah semua equation yang ada. Okay. And then this one pun sama jugalah. The geometric elements of a channel section. So this one to calculate area, weighted parameter, hydraulic radius, top width, D and Z for shape yang lain lah. So we have parabola, round corner, and also round bottom triangle. Okay. So basically yang ni tak akan ditanya lah. So yang the most common shape yang kita akan tanya adalah rectangular, trapezoid, and also circular. Circle pun jarang sebab for the culvert, it's only covers for project. Okay. And then next we have a freeboard. Okay. Like I mentioned tadi. Okay. So basically freeboard is a vertical distance between the highest water level, or here we call it as water surface, to the top of the bank, retaining bank ataupun the channel section. Okay. And then this is the main purpose. Basically it is for safety factor to prevent the overtopping of the structure ataupun nak elakkan banjir lah. So at least when you design the drainage, so we have certain level, certain distance yang boleh elak terus banjir lah in case of heavy rainfall. Okay. And then for rectangular channel, we have two conditions. So the first one, we have ordinary rectangular channel. Okay. So here we have the ordinary, some example of ordinary rectangular channel. Okay. So we have Y for flow depth, B for the bottom width. Okay. And then as you can see here, we have Q. So here the small q, we call it as a unit discharge. Okay, here. And then capital Q, this one is the flow rate, the discharge. Okay, and then here B is the bottom width lah. Okay, so the unit for Q, small q is meter cube per second. This one for the unit for flow rate, and then B is in meter. Okay, so the unit for unit discharge is meter cube per second per meter. So basically saya minta student saya akan tulis meter cube per second per meter. Not tambah lagi slash, not. Just letakkan dot per meter kat sini. Okay. And then so as we know the flow equation, so we have Q equal to AV, the flow area times with the velocity. Okay. And then here's some the derivation of the equation. Okay. So A equal to B darab Y for rectangular. And then V just remain dekat sini lah. And then here you just masukkan yang ni dalam equation yang ni lah untuk replace Q dekat sini. Okay. Oh sorry. Oh ada. Okay. And then this one when substitute equation 2. So the first one unit discharge. This one we rename it as equation 1. Okay, and then to the second one, rename it as equation 2. So we just substitute equation 2 into equation 1. Okay, and then you can simplify. You just cancel out the B, the bottom width for the upper and lower part equation. So you can get this equation. Q equal to Vy. The velocity times with Y, the flow depth. Okay? Boleh? Okay, and then next, for the second types of rectangular, we have very wide rectangular channel. So for the very wide rectangular, so the bottom width is mostly besar lah daripada Y. So this one just the theory part lah. B higher than 10Y. Okay. So the example for very wide, so we have low flow in monsoon rain. Okay, and then low tide in an estuary or wide river. Okay, so bila yang ni lah B, the bottom width, lebar sesuatu drainage tu lebih besar daripada nilai flow depth dia. Okay, and then here just some derivation of equation. So we have A equal to By, and then the weighted parameter for rectangular, we have B plus 2Y. Okay, and then for hydraulic radius, we have R equal to A over B. Flow area divided by weighted parameter. Then we just replace the equation A and P here. And then you can cancel out because of you can cancel out 2Y over B here. Okay. Then after you simplify this one, so you just use R equal to Y. So this equation, R equal to Y, only applicable for wide rectangular sahaja. Okay. So kalau untuk ordinary, you tak boleh guna R equal to Y lah. So you just go to the basic one, R equal to A over B. Okay. Boleh? Okay. Okay, next, we have a circular culvert. Okay, so for the circular culvert, we have two conditions. So for the case one, so the flow depth higher than D, the diameter divided by 2 lah, over the half of the diameter. And then for the second case, we have case 2 here. So we have the flow depth less than separuh daripada ni lah, culvert. Okay, D over 2. Okay. And then this is the equation to calculate the flow area. So we have D square, which is the diameter of the culvert. And then the theta for R to represent the theta in radian. And then sine theta here, which is theta is in degree. Okay. And then to calculate the weighted parameter, we have D over 2 times theta R. When we have R dekat sini, so the theta must be in radian. Okay. And then this one to calculate harrow radius, this one to calculate the top width. Okay. So, ada soalan? So, kalau tak ada soalan, can we take a break for 2 minutes? Is it okay? You want 2 minutes or 5 minutes? So let's proceed with example. Boleh ke? Okay. Boleh. So for example one, for rectangular channel. So given rectangular channel cross section, the flow depth for rectangular channel we have 1.2 meter, and then the B, the channel width is 2 meter, and then the freeboard FB equal to 0.6 meter. Okay, then find TA, T the top width, and then A the flow area, P is the wetted perimeter, R hydraulic radius, and D hydraulic depth. Okay. So this is the solution for rectangular channel. Okay. So this is the sketch for the shape of the rectangular channel. So we have B equal to 2 meter. The flow depth here 1.2, and then we have freeboard dekat sini. So we have 0.6 meter. Okay. And then the side slope we have 0 lah sebab it is a rectangular, not the trapezoidal ataupun triangular shape lah. Okay. So for the flow depth 1.2, and then for the top width, the T, for rectangular channel T also equal to B, the width, the bottom width. T dekat sini kan atas equal to the bottom width. T equal to 2.0 meter. Okay. And then next, you need to find A, the flow area. So the equation to calculate the flow area equal to By. Okay. So B, you just replace the value here. Okay. So B we have 2, and then Y, the flow depth 1.2. Then you will get A equal to 2.40 meters square. Okay. And then next for the wetted perimeter, P. So the equation wetted perimeter for rectangular, we have B, the bottom width, plus with 2Y. Dekat bahagian sini dengan bahagian sini lah. Okay. So B equal to 2, and then Y just replace 1.2 here, then you will get 4.4 meter. Okay. Then you can proceed to calculate the R, the hydraulic radius, which is the ratio between flow area and the wetted perimeter. So A has been calculated here. Okay. So A 2.4 divided by 4.4, the wetted perimeter, then you will get 0.55 meter. And then for the hydraulic depth, the ratio between flow area and top width, so we just divide the flow area and the top width, the T. Okay, so we will get 1.20 meter. Senang je kan? So yang susahnya you just kena hafal the equation. Okay. Okay, and then next for the second example we have a trapezoidal channel. Okay, so this is the visualization of the channel. Okay, so we have B, the bottom width 0.5. Sorry, this one's supposed to be here. The flow depth 1 meter, and then for the freeboard 0.2 meter. Next, we have Z here. Z equal to 1. Okay. So similar with example 1, so you need to find T, A, P, R, and D. Okay. So this is the solution. So for the flow depth equal to 1 meter, then to calculate the top width, so this is the equation. So T equal to B plus 2ZY. Okay. Then you just replace B equal to 0.5, and then Z equal to 1, and then Y equal to 1. Okay, then you will get the top width equal to 2.50 meter. Okay. And then next, to calculate the flow area, so A equal to By plus Zy squared. And then you just replace the value. Okay. Then you will get 1.6 meters square. Okay, and then next for the weighted parameter, so this is the equation. P equal to B plus 2y times with square root 1 plus z square. Then we just replace the values of B, Y, and also the Z. So then just put the value into your calculator. So you will get the weighted parameter equal to 3.33 meter. Okay. And then for R, hydraulic radius, so the value for A divided by P here, then you will get 0.45 meter. And then next for the hydraulic depth, D equal to A over T. So A equal to 1.5 and then T has been calculated here. So you just divide, then you get 0.6 meter. Okay. Dapat jawapan yang sama ke? Ke tak ada yang check pun? Tak ada yang tekan calculator pun? Sebab jawapan dah bagi. Okay. Next, for example 3, for the circular channel, okay. So consider a flow rate. We have Q here equal to 1.5 meter cube per second. And then we have a uniform flow depth, which is Y equal to 0.85. And then we have the diameter of a culvert equal to 1 meter. So you need to find TA, P, and also R. Okay. And then this is the solution. So since the flow depth higher than D over 2, okay, the diameter over the half of the diameter, okay. So so you can refer this one will be the case 1, okay. So for the case 1, you need to calculate H here. And then this one. So sepatutnya lah gambar dia macam yang ni lah. So we have the flow depth higher than the center point here. So you just consider the triangular shape here to be calculated first. Okay. So you need to calculate H dekat sini. Okay. So H equal to the flow depth Y minus with D over 2 yang kat sini. So D equal to 1 divided by 2 equal to 0.5. So you will get 0.35 lah dekat sini to represent H dekat atas ni. Okay. And then next you need to calculate the alpha. Okay. So this one is the theta and then alpha is the degree dekat sini lah, separuh daripada yang. Okay, and then okay. So yang ini, this is the equation cosine inverse cosine 0.35, which is dekat bahagian sini, divided by the hypotenuse dekat sini 0.5, then we'll get the alpha value 45.57 degree. Okay. And then to get the theta, sudah dekat bahagian bawah ni, so you just double up the alpha dekat sini, then 360 just minus with 2 times alpha dekat sini, so you will get the theta. So the theta value is 268.85 degree. And then this one to convert from theta to radian. Okay. And then to calculate the top width. Okay. So this is the equation. D times with sine theta over 2. So the theta must be in degree. So then you just masukkan je lah nilai D, the diameter, and then the theta in degree. Okay, and then we'll get the top width of the channel equal to 0.71 meter. Okay. And then next, for the flow area, so this is the equation, d square over 8 times with theta r, which is in radian, minus with sine theta in degree. So this one you already calculate here in radian. So 4.69 minus sine theta, which is in degree, 268.85. Then we'll get A, the flow area for the channel, equal to 0.71 meters square. Okay, and then next, for the wetted parameter, so we have P equal to D, the diameter divided by 2 times with the theta in radian. So here you just replace the value. Then you will get P, the wetted parameter, equal to 2.35 meter. Okay, and then next for the hydraulic radius, R, which is equal to A over P. So A 0.71 divided by P 2.35, then you will get 0.30 meter. Okay, boleh? So I think that's all for chapter 1. Senang je kan chapter 1? Sebab yang ni just basic matematik lah, darab-darab macam tu je. Okay, and sekejap ya. Okay, so let's do some tutorial. Boleh ke? Ke nak stop kelas dah? Okay, boleh. So let's do question 1. So I give you 5 minutes to solve this question. Is it okay? Okay. Okay. So already familiar, right? So can someone share the answer? So what do you get for the A, the flow area? Okay, 10. So what is the equation for area? Okay. So we have A equal, sorry. So A equal to By. So the answer is 10 meters square. Okay. And then next for weighted parameter of, sorry, the second one is hydraulic radius, R. So in order to calculate R, so you need to find P first, the weighted parameter. So the equation for P, so we have B plus 2Y. So this one you get berapa? For P, weighted parameter. 9 meter, okay, correct. And then next for R, so R equal to A over P. So this one you will get 1.11 meter. Okay. And then for the third one, for the velocity, so how to calculate V? Yes, you can use V equal to Q divided by A. So you just use a general flow equation. Okay. So we know that general flow equation Q equal to AV. Okay. Then just rearrange this equation. So you need to find V. So this one become Q over A. So your Q equal to 6.5 and then your A equal to 9. So here you will get what is the answer for V? Zero point.
Doktor,
Yeah.
Q over E bukan sepatutnya 6.5 over 10.
Oh,
Bukan.
sorry.
Apa?
So this one. Okay, thank you. So 6.5 over 10 equal to 0 point. Noranisha, sorry. Yang area tu is 10, not 9. 9 is the weighted parameter. So this one will be 0.65. What is the unit for velocity? Meter per second. Okay. So nak ingatkan nanti kalau tak ada unit saya tolak markah tau. Kalau test ke exam ke. So make sure you put the units, okay? And then next, for the next question, you need to calculate the fruit number. So what is the equation for fruit number? So we have FR equal to V divided by square root GY. Okay. And you just put the value of V equal to 0.65. Okay. And then G, what is the value for G? The gravitational acceleration. 9.81. Okay, betul. And then the value for Y, 2.5. Okay. Okay, betul. So the answer is 0.13. So just use two decimal places. Okay. So 0.13, which is less than 1. So this one we can classify sebagai apa? Which type of the fruit number? Subcritical, betul. So this one is subcritical low. Ataupun kita boleh tulis sub C je lah. Okay. And then next, the volume of soil to be excavated if the length of the channel is 500. Okay. Then how to calculate the volume? Then you need to find the area, new area times with L lah kan. L yang diberi yang ni lah 500. And then to get the area, so yang ni you kena consider freeboard sebab dia nak excavate for the whole area for the channel cross section. So you tak boleh nak just consider flow depth saja. Okay. So this one, the equation is FB plus Y then times with the B. Okay. And then barulah you darab dengan length. Okay. So 2.5 tambah dengan 0.3, so you get 2.8. Darab dengan nilai B 4 meter. Then darab dengan 500. So you will get 5,000. Is it correct, Aina? Try recalculate. So you will get 5,600 meter cube. Okay. Okay. Okay, yang ni untuk contoh the example for rectangular lah. So untuk rectangular dia agak mudah sikit lah. Ini. And then so try buat pula untuk soalan yang kedua lah. Boleh nampak ke? Tak nampak. Soalan. Boleh nampak ya? So for example 2, we have a 150 long trapezoidal canal with bottom width B 3 meter, and then the side slope Z 3, and then the flow depth is 4 meter. Then you need to find T, A, P, R, and D. And then for the second question, to determine the types of flow, if the discharge Q equal to 120 meter cube per second. And then the third question, the lining cost. If RM8 per meter square lah untuk lining cost. Okay. So insert the equation. So what is the equation for T? Equation T for trapezoidal channel. So T equal to B plus 2ZY. Okay. And then the B value is 3 plus 2 times with Z the value is 3, and then Y value is 4. Then the top width of the channel equal to dapat berapa? 20? Okay, 27 meter. Okay. And then next for area. So what is the equation for area? By plus zy square. Okay. Then we just replace the value for B. We have 3. And then times with Y 4. And then next we have ZY. 3 times 4 squared. Okay, betul. So, terima kasih Alina. So, sekejap eh. So, jawapan dia adalah 6. Okay, next untuk P, for the weighted parameter. So for P, the equation P equal to P plus 2y times with square root 1 plus z square. So nilai B, just replace 3, and then y equal to 4, and then z here equal to 3. Okay, so terima kasih Nuralish. Okay, the answer is 28.3 meter. 30. Okay, and then next for R, hydraulic radius. So R equal to A over P. Oops. A 60, and then for P 28.3. So the answer, okay, betul. 2.12 meter. Okay. Oh, semua dah hebat-hebat lah. So boleh dapat full mark untuk test 1 lah nanti. Okay, and then dah. So ada lagi satu which is D. The yeah, betul Aina. So dapatkan nilai the hydraulic depth which is D equal to A over T. So the T is 27. So this one equal to 2.42. Okay, betul? Okay, and then for the second question, determine the types of flow if the discharge Q equal to 120 meter cube per second. So this one, in order to determine the types of flow, so you need to find the Prudhoe number. Okay. So what is the equation for fruit number? So we have FR equal to B divided by square root GD. So kena dapatkan nilai V dulu. Okay. So V equal to Q divided by A. So Q 120 and then A we have 60. So this one become 2 meter per second. Okay. And then using this equation, so you just replace the value for V. So V equal to 2 and then G 9.81. And then for D, D is the, how do I write that? 2.22. So the fruit number 0. Betul. Betul. 0.43. 0.43, which is higher than 1. So this one classified as sub subcritical. Okay. And then the last question, the lining cost of the channel if the unit cost is 8 ringgit per meter square. Sekejap, sorry. Sorry, this one less. So yang tadi less. Okay. Then macam mana nak solve for the third question? So to solve this one, you need to find the side length dulu, W. So this one, for the W, the side length equal to Y times square root 1 plus Z squared. So Y dekat sini, you kena consider tiga dekat bahagian sini. Yang hitam ni adalah 3 because it depends on the Z value here kat sini. Okay, and then plus with 1 dekat sini, sudut sending. So this one, sorry, this one is mana? 4 Y. Okay, and then nilai Z dekat sini equal to 3. And then you kena tambah dengan 1 dekat bahagian sini. Sorry, this one tambah 1. Okay. So yang this equation Y times square root 1 plus Z square, this one the side length for the yang hitam ni saja. Okay, which is the length yang touch the water, maksudnya yang bersentuh dengan water sajalah. And then you need to consider 1 meter dekat sini sebab it's consider the channel section, which is lining ni kena semualah for the whole section. So dia tak boleh pergi lining dekat dekat kawasan permukaan air je. So dia kena consider whole lah. So you kena dapatkan the side length at this part and then plus with 1 meter given here. Okay. Then here plus 1 lah. So the value for the side length equal to 13 point. Okay, betul. So 13.65. Okay. So the unit is in meter. Okay, and then next you need to calculate the P. So here for the weighted parameter, we have B plus with 2W. So as you can see here, Y times square root 1 plus Z square also equal to W. So this one we just replace with W. Okay. Then B we have 3 plus with 2 times W, 13.65. Okay. Then here you will get 30.30 meter. Okay. And then to get the lining cost, so P, the weighted perimeter times with L, the length, then you need to times with the cost. RM, RM8 lah. Okay. So P equal to 30.3 And then L, we have 150 times with 8 ringgit. So you get the lining cost equal to 36,000. Betul. So 36,360 ringgit. Okay. Okay, and then stop. So maybe for question 3 and question 4, so you can do on your own as a homework. Is it okay? Okay. Then we will discuss the answer for the next week class. Okay. So this question you can download in e-learning. So just guna yang ni je lah sebab tapi yang ini saya tak lupa ubah sebab we have a problem to untuk backup e-learning yang sem lepas sebab yang ni saya backup guna saya restore guna this semester yang lama lah. So we just only have this example or tutorial question on the e-learning. Okay. So itu saja untuk hari ini. Is it okay if we just finish it earlier? Ke you nak terus sambung another topic? Okay je? Okay. Okay, bye-bye. Okay, that's all for today. So thank you. So siapa yang tak scan lagi attendance, please scan dulu lah. Okay. Oops. So maybe yang tak boleh scan tadi nanti you scan through e-learning. Saya akan upload the QR code in e-learning. Okay. Okay, bye. See you again in next week.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Okay.